There's a more concise, convenient way that you can represent a summation, and that's with a sigma. Now, you've probably seen a sigma before. You might have seen them like in association with college fraternities and sororities and that type of thing, because it is just a Greek letter is all that this is. So there's our sigma right there. When you see sigma, it always automatically means summation. So they won't say add these numbers. It will just say sigma, and from that we're supposed to understand that we're supposed to find the sum of those things. Now, we have an index of summation down here on the bottom. Sometimes that's I, like it was here. You can see down here later on it's K, sometimes it's J. There's nothing magical about that letter. That's my index of summation. And then there's a lower limit of summation and an upper limit of summation. And what that lower limit and upper limit tell me are where to start and where to stop. So for instance, the way that I would read this sigma is I have the summation of A sub I, where I is going to start with 1 and stop with whatever number might be up here. So what I'll do is I'll start by putting in 1, and then I'll put in 2, and then I'll put in 3, and then I'll put in 4, and I'll just keep right on going until I get to whatever number might have been on the top. Look at an example. For this first one, we've got the summation of 3i from 1 to 5. So literally what they want me to do is they want me to start by putting 1 in the place of I. So I'll put in 1, and then I'll put in 2, and then I'll put in 3, and I'll put in 4, and I'll keep going until I get to this upper limit of summation. So since that upper limit was 5, then once I plug in 5, then I'm going to stop because that was my upper limit. So it's the same kind of thing as if they had said find the first 5 terms of this sequence. Right? When I see the summation symbol, again, there's nowhere that it's going to tell me to add, but that will tell me that they want me to go back and find the sum of each of those 5 terms that I just found. So I could go through then and say, okay, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, add those up, and I'll have 45. Page 623, they tell me that what we've been doing up to this point, where we have been going through and plugging a number into a formula and coming up with a list of terms, that's a sequence. But now today, when we've been going through and we've been adding those terms, when you find the sum of a sequence, that's a series. And both sequences and series can be finite or infinite. When they say finite, that would be like find the sum of the first 5 terms. We want to stop at 5. That's finite. But if they said, they put ellipsis dots on the end, or they said let it go into infinity, then that would be infinite. There are 2 different types. So for also in the middle of page 623, they give me one more bold print term, and that is nth partial sum. And they tell me that the nth partial sum is just the sum of the first n terms. So if they said find the 5th partial sum, that would be the sum of the first 5 terms. If they said find the second partial sum, it'd be the sum of the first 2 terms. So example 8, they say for this series, because it's the sum, for this series, the summation from 1 to infinity of 3 over 10 to the I, find the 3rd partial sum. So the 3rd partial sum means the sum of the first how many terms? 3, right. So it's just as if they said start with 1, and if you're going to find the first 3, you're going to find 1, 2, and 3, right? So it's just as if they told me to stop with 3. So they're not going to write it that way, but I could get that from 3rd partial sum. Start with 1, just give the sum of the first 3 terms, okay? So we're going to go through and we're going to plug in 1, plug in 2, and plug in 3, just like we were doing on the first half of this lesson and on the first half of this section in the previous lesson. Now, if I simplify those fractions, I'm going to have to get a common denominator, and it might be easier just to write those as decimals. So I'm going to write 3/10 in its decimal form, 0.3, and then 3 100ths, 3 1,000ths. And then to add them, I don't have to do the whole common denominator thing. So that'd be a little bit easier. So that would be the sum of my first 3 terms. The second part says, just find the sum. Okay, well I go back to the original problem and it said find the sum from 1 to infinity. I'm going to be doing this one problem for the rest of my life apparently. If I'm finding the sum from 1 to infinity, right, I just keep adding numbers on and on and on forever. Well, I cannot find an infinite sum of everything, but there are specific types of problems that I can find the sum of them going to infinity. And this is one of those scenarios. So if I start the same way I did a second ago, where I plug in 1 and I plug in 2 and I plug in 3 and maybe I plug in a couple more of them and just show, it's going to keep going. Again, I'm going to write those as decimals because I think it's a little bit easier to see. I've got 0.3, 0.03, 0.003, 0.0003, and I start to see a pattern. What would the next one be without me having to even plug it in? Yeah, it's going to have 4 zeros, and the next one's going to have 5, and the next one's going to have, it's just going to keep on going, right? So if I add those together, what am I going to get? Yeah, 0.3333, I'm going to get 0.3 repeating. And isn't 0.3 repeating 1/3? So I'm able to find the sum of something that goes to infinity. And again, I'm only able to do that in very specific settings. I won't be able to do that for a lot of things. All right, now your calculator will also do these summations, but it kind of depends on whether you have an 83 with the old operating system or you have an 84 with the new operating system. So if we had the summation from 1 to 3 of 3 over 10 to the I, that one we just did that we got 0.333. If you have the old operating system, you are going to go to second stat, which is list, and you're going to scroll over to math. And that's where you'll be able to scroll down to find sum. So you'll put that on your main screen, and then you'll go back to second stat, which again is list, but this time go over to operations and scroll down to sequence. So you can tell it, take the sum of the sequence, give it the equation, comma, your comma is right above your 7, right beside your parentheses. Tell it the variable you want it to use, which again would be n, comma, the lower limit of summation, comma, the upper limit of summation, and it will give you that answer. I think I might have been able to work it by hand a couple of times by the time I did all of that. If you have an 84 with the new operating system, it is significantly easier, and it actually looks like a summation. So if I do alpha window, see right above window in the same color as your alpha button, you have that F2 button. So I'm going to hit alpha window to get to that F2, and when I do, I pull up a whole function menu. We've done absolute value here before. But that second one right there, that summation, if I choose number 2, it literally puts a summation on my screen that I can fill in the values. It's already flashing an A right there for alpha mode, so you can use whatever variable you want. Since mine was I in the original problem, I just chose I, but you could choose whatever you wanted. So I was right above x squared, and so I just hit x squared and it gave me I. And then I told it to start with 1, so I put a 1 right here and I put a 3 right here, and then I typed my equation right here and hit enter, and it gave it to me as a fraction, or I could ask it to change that to a decimal. So play around with that a little bit and see if you can get that to work, okay? Now, when we were working on this, probably the hardest thing that we were doing on the first half of this lesson was having to create formulas from just random lists of numbers. And I promised you that we would get some formulas for that. So I want to go just far enough into this next lesson to put your mind at ease so you can see we really are going to get formulas for these. If they give me a list of numbers like they did on the first half of this section in the book, we were going through and we were looking for a constant difference. Like we did 11 minus 7 is 4, 15 minus 11 is 4, 19 minus 15 is 4. We got a constant difference of 4 by doing second term minus first, third term minus second, and so on. If you find a constant difference on your problem is arithmetic. If you go through and you don't get a constant difference, then it's simply not arithmetic. If your problem is arithmetic, we now have a formula for finding the equation that goes with that. A sub n is equal to dn plus c. So I would start the same way where I go through and say term 2 minus term 1, term 3 minus term 2, get my constant difference. And my formula will be a sub n is equal to that difference, 3, n plus c. Then all I need to do is find c. And c is going to be my first term minus my difference. So my first term was 2, and my difference was 3. So that C value would be negative